Our third set of problems deals with the specific heat capacity. So the equation when we're trying to find our specific heat is Q is equal to mass times the heat capacity of this substance that is in the problem times the change in temperature, or delta T. This problem, we need to calculate the amount of heat required to raise the temperature of a 65-gram sample of water from 32 degrees Celsius to 65 degrees Celsius. So just by looking at the problem, we can see that our 65 grams is our mass, our 32 degrees Celsius is our initial temperature, and our 65 degrees Celsius is our final temperature. Because delta T is also final temperature minus initial temperature. So now let's fill in our variables. So we're trying to find heat, which is Q. So Q is equal to our mass, 65 grams, times our specific heat capacity of water, which if you look in the book, the heat capacity of water is 4.184 joules per gram degree Celsius times the temperature change, which would be 65 degrees Celsius minus 32 degrees Celsius. Now if you notice, all the units cancels out except for our joules, which is what Q is. So when we input this into our calculator, we get 8974.68 joules. Now we need to convert this, or rather change this answer into our 2 sig figs. So in order to find 2 sig figs, let's underline up to 2 digits here. And we'll see that this 7 would round this up to a 0. But since it's a 9, this will go to a 9. So the final answer is 9,000 joules. Our next problem is asking for our temperature change. So an easy way to do this is to rearrange our equation to get the temperature change on the side by itself. So if we divide both sides by mass times specific heat, we then get delta T is equal to Q over MC. Now all we need to do is add our variables in. So we have delta T is equal to 57 joules divided by our mass of 17.1 grams times our specific heat capacity of aluminum, which is, if you look in your textbook, 0.903 joules per gram degree Celsius. Okay, so all the units will cancel out except for our temperature. So joules cancels out and our grams cancels out. So we are left with 3.6913 degrees Celsius. Now this problem, the fewest number of sig figs present is our 57 joules, which is 2 sig fig. So this needs to be in 2 sig fig. So our final answer then is 3.7 degrees Celsius. Our last problem, we are trying to find the heat capacity of the liquid. So we are given our Q value, we are given our M value, and we are given our delta T value. So to make this easier, let's put our heat capacity on the side by itself. So we're going to divide both sides by mass times delta T. So we're left with specific heat capacity is equal to Q over mass times delta T, which is equal to 47.5 joules divided by 13.2 grams times 1.72 degrees Celsius. Now, if we put this in our calculator, we will get the answer 2.09214 joules per gram degrees Celsius. Now, to put this in correct sig fig, it looks like it is 3 sig fig for this problem. So we need to convert this into 3 sig fig. So the answer is 2.09 joules per gram degrees Celsius.